Aldol condensation is used to combine two molecules into one, and it's often accompanied by dehydration of the primarily formed beta hydroxy aldehyde or ketone. As shown here, it's a self-condensation oftentimes, and thus you need two molecules, and they combine into one new molecule, and the key linkage is going to be between the alpha carbon of one molecule and the carbonyl of the second. If the initial product is heated, oftentimes we'll get the alpha beta unsaturated product, which would result from dehydration. This dehydration is facilitated due to the resulting stability of the conjugated eneal in this case. The aldol reaction generally works better with aldehydes than ketones because aldehydes are slightly more prone to enolization or enolate formation. Classic mechanism. In this case, I'm using F oxide as the base, so the first step is going to be to remember to put in your alpha H, abstract the alpha H, forming the classic enolate of acetaldehyde. And recall that this enolate has two resonance contributors. One that shows the negative charge on the oxygen of what was the carbonyl, and the other which shows the negative charge on the carbon, which is alpha to the carbonyl again. And since it's a self-condensation, in this case we've formed our enolate, and now we can condense it on another molecule of the same original aldehyde, again in this case acetaldehyde. And you could choose either version of your enolate in your mechanism. In this case, I'll just use this form. And the key step is again to realize the alpha carbon has a significant nucleophilic character, and the carbonyl has an electrophilic character, so the connection can be made like so. And the resulting species then would look like that, where this carbon is that one, and again that's the alpha carbon that we've connected to the carbonyl carbon. And upon workup with adding a proton, we arrive at the beta hydroxy aldehyde. If we heat the beta hydroxyaldehyde mildly in either acid or base, we can get a E2-like elimination, forming water and an eneal. Eneal because it's an ene, al because it's an aldehyde.